Hello, today I'll show you how to take one Gotek drive and convert it to a flash drive. The flash drive is a firmware that allows us a more advanced usage of the Gotek drives. So this is a Gotek drive. It is a floppy emulator that allows you to connect a USB flash drive with these images and works as a real floppy drive using sugar and compatible buses. And I'm going to show you how to modify to add a speaker, an OLED screen, and a Rotary encoder, and flash it with the flash drive firmware. The flash drive firmware allows it to be compatible with formats from Amiga, Artery, and so on, even from some copy protections, while the Gotek standard firmware only allows you high density PC floppy drives. The first step is to remove the Rotary encoders from their PCB, because otherwise they just don't fit inside the Gotek case. So it's as simple as the soldering them from the back side, and then we can directly attach solder cables to connect it to the Gotek PCB. All the Rotary encoders out of their PCBs, so they're smaller. I'm going to measure them with a caliper, and then I also measure the piezoelectrics, so I know what size to make holes on the Gotek case. I'm going to put the Rotary encoder here next to the buttons. I'm thinking about putting the piezoelectric somewhere like here, or maybe here. Well, let's see how it goes. So now let's measure them, and the next step will be to open them and solder the headers on the PCB so I can connect all the hardware mods, as well as the headers needed for flashing the firmware. The headers are all soldered. They're not really needed unless you're going to install mods, because you only need to jumper these two. So I'm going to take this jumper, these two, to enable the boot mode, and use DFU because this is a newer model. This is the Artery model Gotek. So this is flash a different way. I will put link in the description for both ways of flashing it with the STM32 as well as this model, the Artery. But the Artery you don't really need to do it just for flashing, only for modeling. Also I need to solder headers here on the OLED screens because they don't come with header solder. And that's good because they may solder on the ground side. So this is the side that goes out to the case, so I'm going to solder them here. Okay, the first thing we're gonna do, as we have the Artery version of the Gotek drive, is download the Artery software. So we go to www.arterytech.com. It's going to show everything in Chinese. Doesn't matter. We select here app where it says CN and we put EN, and we'll have the English page. We come here and select any of the 8032 series, and then go down until the software, and we select the in-system programming tool. This only works on Windows. I have not checked if it works on a virtual machine. It will probably do. I'm just recording this on Windows. Now we open it. Okay. And then we're also going to download the FlashFloppy firmware, the latest version. So it's github/kirf/FlashFloppy. I will put all the links in the description. Just download it. Okay, have it as well. And I will extract everything to the desktop here. And while it extracts, I will use a USB-A to USB-A course cable to connect the board, and use a jumper here, this one, to cross on G3 the boot. So it's going to power up in boot mode, and we can reflash it. So I'm going to plug in now. It's slightly hard. There's no light indication or anything. Should appear shortly on Windows unless my it will say that there's no provider for Artery. So let's install the driver. I suppose this is the one. Doesn't give you an option to choose anything. It will take a minute or longer than a minute. Sometime. Says installation can take some time. It has already been some time. Please continue. Yeah, this Chinese software is slow. Meanwhile, you should have prepared one of the OLED screens as well as some cables, because the cables that come are square. You cannot put them linearly like those ones. Says restart the computer. I won't restart the computer. I should just take it already. So let's see the I can see the device manager. Let me check for the device manager. Okay, we can see the device manager has already installed the driver, doesn't need to reboot. Now we open the ISP programmer here. Again, complaining that it's not a non-publisher, just run it. Now we choose USB DFU, it will detect it. Okay, now we choose next. Say it's in read protection, the device is limited, that's okay. They don't want us to read the Gotek firmware. It selects everything automatically, the flash mapping, everything, there's nothing you can do here. So the first thing is to disable the read protection, and the moment that we disable the read protection, it will erase everything that's on it. It will tell that everything is erased, and just let it run. It should say this. If it says any error, try it again, close the program, connect to another port on the computer. It may show that it has already disabled the protection because it just didn't connect it after disable the protection. Just click it again, open it again, and now we're going to flash it. So again, USB DFU, we have charges routable 8052, blah blah blah, and then just download to device. I think it was this one here, and we need the FlashFloppy. We need the hex file here. So we add here on the desktop FlashFloppy the hex file. We're checking that there's no other option that we need to set up here. We have enable verify obviously and erase everything, and now just flash it. It doesn't guarantee us the security of the code. Yeah, no problem. So it's now running. If everything goes okay after flashing and verifying, it says successfully finished. You can close it. And now we disconnect it from the computer. It's a little hard. We get the DuPont cables, remove the boot jumper, let's put it somewhere else that doesn't matter. Now the connection is like this. So I'm going to put yellow here to ground. It's not the most appropriate ground, but okay. Then brown to VCC. Red to SCN, orange to SDA. And now the screen is connected. Now to put it here, so we look at it like this. Let me untie this cable. So if we put it like this, so we see like this. So down is yellow and brown, and those two go like this. So brown, yellow, and the other one is red and orange. So red goes down, orange goes up. And if everything is okay, we plug the power. and we shall see FlashFloppy appearing on the screen. And if it's not okay, you may have burned your board, you need a new one. And you see FlashFloppy on the screen, so it's properly flashed. Now, after flashing with FlashFloppy, any update is done through the USB stick, so there's no more need for using this software or anything like that. You can install it if you want, or if you are going to get new Gotek drives, just leave it installed for new installations. Now everything is finished, only assembly left to do. So to glue down the piezoelectric speaker, I have used a special glue for plastics is slightly corrosive, but the advantage it has is that it solders one plastic with another, so this is not going to go anywhere. For the rotary encoder, I have used the epoxy. You cannot see it very well on the camera. Let's see if I can zoom it. Okay, it's still curing because I have just applied it and it needs 24 hours. But with this epoxy, it's not going to go anywhere. It's going to resist the force of pressing the rotary encoder. I have soldered the cables according to the wiki. I have put the header ends here, so it can be replaced from the motherboard. As for the screen, I used hot glue because hot glue is resistant enough and is not corrosive, and this will hold the screen in place, and the screen gets very near, so there's no much of a difference. You can file this better than I did. This is holding it until it cures, just blue tack, so I can remove it easily. And now the only left thing to do is to connect the motherboard, the Gotek PCB, to all the cables and so on. In this case, because it's a Artery one, is slightly different how to connect the encoder, because on the STM ones there are two extra headers here. However, on this one they are not here, so we need to connect it here. I'll show you in a moment how to connect it when I can put the camera in a better place. As for the speaker, it connects in the same place, GB. And as for the screen, I have reused the connector, the 2x2 connector that came, and used this new kind of solder joints that I tested to join loop-on cables and plug into the screen PCB. So yes, I only need to do this, and okay, it's not so easy to do with only one hand. And now, come on. Okay, and now the screen is connected. Yeah. So I will connect the rotary encoder and show how everything gets finished. Well, this is how it looks. So the cables are here, going through the sides for the speaker and for the rotary encoder. I have connected to power to test it. The speaker is here, so it gets the sound of the case of the Gotek. And then the screen is not very well visible now. Okay, the screen, the USB, I still have the buttons and the rotary encoder. So now let's put the power and try it. Power on. So we can see already the menu here. We click and can move with them through the menu, or we can plug in a USB stick. Sorry, it lost focus. And plug a USB stick, and now we can move. So exit to selector, or move folders, images, etc. And if we want to choose, for example, this, okay, chosen, or enter the menu, exit and reset, and so you can adjust the different features of the LCD configurations and of the speaker, and also the mode, because this is mostly a sugar compatible, but sugar compatible is a very generic term. It can be defined for Amiga, for Atari, for PC. It can work on every computer practically that uses floppies, except for the Apple computers, and it has several differences on the bus that can be configured with a file on the USB flash drive. One of the problems of the Artery is that it has less RAM, but it's practically impossible to get the STM32 now from the Chinese manufacturers. This half RAM means that on some kind of images you need a much faster, much better USB flash drive than you needed with the STM32 model. In this case, this is a Philips branded flash drive, but it's crap. It's absolutely crap. I don't expect it to work properly with the high HFE format. But it doesn't matter, I'm not going to use it much, so it has not gone to sleep. And well, it's working, so if you follow these steps you should have it pretty easily. Now, as for the wiring of this, just look at the wiki. The diagram on the wiki shows the rotary encoder looking up, so looking this to you instead of on the other side, so take that in account. and then I'll always try to check if this is ground. You get it on the PC mounted, it has a pin that says ground. Sorry. You can use a multimeter to test. Do it. Always be sure. Because you have to connect the ground to another pin on the rotary encoder. As for the speaker, it shouldn't matter, but I have put ground on the side of ground. That's the left side right now, as seen from this. So the downside, as seen from the video, and the plus side there, and the screen as well. It has a polarity, so you need to be sure, check everything twice before using glues or anything that will prevent you to go back and fix a mistake. I hope you enjoyed this video and you use the Gotek for a lot of fun. It's a very useful floppy emulator for a lot of machines. I plan to use it on a PC, on a RISC PC for an Ikson, on a Atari ST, and even for development of Artery on a more modern PC. Indeed, I have one here on a Dell computer on a Core 2 Duo that I'm using on Linux, on 64-bit Linux. Still floppy works, but I plan to change it with this one and do the same, put the Rotary encoder and so on to all of my models. That one only has the screen. And don't forget to like and subscribe if you want more content. Bye!